Hey, good morning, everybody. And welcome to our webinar today. Today, I'm going to be talking about the Rockwell's brand new M100 motor starter. But just to introduce myself, my name is Joe Daly. I'm the Industrial Control Product Manager here at Gerrie Electric. I've been with Gerrie Electric for 25 years, working in both the automation group, also various other positions here at Gerrie throughout my career. But here today, we'll want to introduce you to Rockwell's latest motor starting technology, and it is known as the M100 electronic motor starter. So just a little bit about the M100 motor starter. It's a smart connected starting solution. The M100 electronic motor starter is designed to enhance the reliability, efficiency of your motor-driven systems by combining functionality of a contactor and overload relay, all in the exact same form factor. And just some of the main enhancements for the M100 motor starter: it's enhanced performance and reliability, improved panel footprint, and reduced engineering and complexity. So to do a quick overview of the M100 motor starter, so too far. So the M100 motor starter just enhancing performance and reliability. So basically, M100 streamlines panel wiring, minimizes components and engineering complexity, and serves as a foundation for motor control portfolio to facilitate a smart, safe, and eventually a connected enterprise. So eventually there will be communications available in the M100 motor starters. So some of the benefits of the M100, you got 78% reduction in panel space, and I'll demonstrate how that actually works, and 50% reduction in wiring. So essentially for reduced wiring, the streamlined design of the M100 allows for reduced wiring and panel build costs. Also, the space savings optimization supports zero stacking with absolutely no derating up to 55 degrees Celsius. The M100 allows for flexibility in installation without compromising performance. There's also versatility in operations. The M100's ability to support direct online, reversing and safety operations, all in the same form factor, makes it a versatile solution suitable for various operational scenarios. And proven efficiency metrics with quantifiable efficiency gains, including up to a 75% reduction in the number of components required, and up to 56% reduction in wiring costs, and up to a 78% reduction in required panel space. The M100 empowers you to take your application to the very next level. So this is also it for comprehensive safety features. Standard in all M100 motor starters. Each M100 has electronic overload protection, phase loss detection, and also phase imbalance and well detection. The safety models adhere to the UL 61508, which is also SIL 3 and Performance Level E, the safety functionality within the same form factor. So I want to walk you through panel space optimization. So in this particular case, we have like a standard motor starter setup. So in this case, we've got 9 100C contactors wired in both reversing and non-reversing configurations. And with that, we've got six safety contactors as well for a safety design. It's included in the design. So significant wiring is needed to complete the design. Additional complexity would be added if, just say, we were to take these 2-component motor starters and make them a 3-component motor starters, which you would have to add a total of 6 overload relays to this design as well. So this would be kind of your typical design. Now, by introducing the M100s, the 9 100C contactors are replaced by 6 M100 motor controllers. So, and also basically 4 of the safety contactors are removed from the design and were replaced with the safe torque off versions of the M100. Reduction in wiring is speeding up the process and reducing the possibility of errors. So you can see right there the panel space that you've saved just by switching to the M100s. And then we can take it one step further with the zero stack. So in many cases, clients will zero stack the M100s, creating additional space. So you can actually add up to 4, in this particular example, you can actually add up to 4 additional starters, M100 starters, and still not touch the panel space that was once occupied by the 100C contactors. So this is where you get that 78% reduction in panel space. Any questions on that? Okay, let's keep forward. So let's look at next generation performance. So basically, adding M100s to existing system is quite simple with the use of removable terminal blocks that are standard with all M100s. Just allows for easy installation and less complex wiring. Connectors that you can see common with all M100s, the non-safety versions. You have your 24-volt DC power connector, your power line connector for your 3-phase or single-phase power, your control connector for forward, reversing, and a couple outputs. Also, your power and load connector. The key differentiator between the non-safety and the safety version of the M100, you get the addition of a safety connector, which is a 2-channel safety operator. So it needs to see 24 volts on each channel for completion in the safety system. Some additional features with full voltage PC-based electronic motor starter includes point-on-wave technology, and I'll talk about that in the next slide. Zero stacking without derating, wide amperage range, and also built-in overload, phase loss, and weld detection. So how do these starters really work? Well, Rockwell has developed a technology known as point-on-wave technology. And it's a process of opening and closing the relays at specific point of the voltage or current waveform. So if you can imagine an AC sinusoidal waveform, the relays get turned on and off at the 0 crossing points. So that way, very little to no energy is transferred during the switching. So with point-on-wave technology, the M100 allows you to improve and maintain energy efficiency, reliability, and durability, flexibility, and component life, less contact stress, and reduced thermals. Now, with this technology, Rockwell has actually got 40 different patents on the point-on-wave technology and related technologies towards it. So this is a technology that Rockwell has developed on their own. So how exactly does it work? Well, we've got oh boy, this didn't quite turn out the way it should. Well, we got two different quick videos here that kind of demonstrate without point-on-wave and with point-on-wave in action. So without point-on-wave, this is kind of without point-on-wave. I don't know if you can see the video that well in this particular case. Yeah, you can see basically there's usually a large explosion because you're switching the relays on at various different points within the sine wave. Now, if we look at the point-on-wave, you'll see there's very little to no spark whatsoever in the point-on-wave video. So that's because that's where the relay is actually turning on at the 0 crossing mark. So once again, going back to zero stacking with no derating. You can zero stacking with motor starters. A significant design technique allows multiple motor starters to be mounted side by side without requiring additional space for any heat dissipation. So that's the example we used before with the panel optimization. So also we got amperage range. So we got wide amperage range for any application. So with our 9 amp models, both safety and non-safety, they can accept any motor from 0.75 amps to 9 amps. And then the 23 amp versions, any motor with full load amps, 4.6 to 23 amps. So the common features amongst the 9 and 23 amps units, you've got direct online and reversing capabilities, removable terminal blocks, integrated electronic overloads, phase loss, imbalance, and well detection. Right now, all models are 24-volt DC controlled. There will be future releases where there'll be other control voltages available. And single or three, it can operate any motor, single or three phase, up to a maximum of 480 volts. So that is the limitation of the M100s. So some of the key takeaways is the advanced functional safety. The M100s, the safety models of the M100s adhere to UL 61508, SIL 3, and PL performance level E. It's got embedded protection, full overload capabilities, and simplified installation. So those are our main key takeaways. And if you're looking for more information on the M100, you can simply contact myself, Joe Daly, here at Gerrie Electric. I can definitely provide you with the installation instructions and user manual. On av.com, you can find the M100 overload videos, and also all this information is also available on av.com. So with that, are there any questions?
So to adjust your overload current, is that those push buttons on the front of it? You can.
No, excellent. No, excellent question. So what I'm going to do right now, I'm going to stop sharing my screen. And I'm going to turn my personal camera on so you can see it better. So the overload is adjusted by this front dial right here on the M100 motor starter. So this is the 23 amp safety version of the M100. So yeah, that's where you would adjust your overload. This is the reset. There's two dip switches. The top one is for if the motor is single phase or three phase. And the bottom one is simply for the overload functionality. Is it going to be automatic reset or manual reset? So those are your main controls right there on the M100.
Is there any applications that these are not suited for, like pumps or I was thinking compressors, anything like that?
As far as I know, if you can start a motor across the line, there's really no limit as to which motors they can and cannot operate with. If the motor can start across the line.
What about trip? Like, isn't there adjustments for trip times with different curves or something like that?
This is trip class 10 only. That's what these were designed with. So trip class 10. So just to remind people about what trip class is. Trip class is the time allowed, the time that the motor starter or the overload will allow an overload condition to exist before it trips. These are trip class 10. So that indicates that it will allow an overload condition to exist for 10 seconds. After which, if that overload condition is still present, it will then trip in an overload. So, yeah, those are, unfortunately, that's not adjustable, but that could be a future release where they could have other ones. So this is the 23 amp safety version. I've also got a 9 amp. As you can see, the size differentiator between the 23 amp and the 9 amp. This is the non-safety version of that of the M100. Pretty much the same thing, except the color is different, and there's no safe torque off indicator light. That's present in the safety versions. I've also got the 9 amp safety version as well. So that's it's basically the two 9 amps, one safety, one non-safety. So those are basically how it works, and that's kind of the depth profile of the M100. And the 23 amp is, you can see, wider and a bit taller the night, actually, this would probably be a better contrast, non-safety, because it's a different color. So they're a bit, the 23 amp is a bit taller, but it's also wider. Okay. Any other questions? Okay. Okay, well, thank you so much for your time, everybody. This is, I just wanted to give you an introduction to the M100 overload relay. If you do have any further questions, please feel free to reach out to myself, jdaly@gerrie.com, and I'd be more than happy to answer any questions you might have. Thanks for your time, everybody.
Thanks, Joey.
Awesome. Thanks, Joe.
Thank you, Joe.
Thanks,
Stop
Joe.
recording now.
Yeah,
Thank you,
the
Joe.
video, those videos,